Hey guys, this is Mrs. Harbin, and this is section 2A.2. We are taking just a brief break from what we've been doing in class to do this mini lesson on graphing and linear equations. This is not new information. This should be a reminder, things that you've learned before, but maybe it's been a couple of years and you needed just a brief reminder. So that's what we're doing here. For our lesson opener, go ahead and simplify these fractions, these terms, these expressions, reducing all fractional answers to the lowest terms. Let's take a look at this. How would you simplify this? Well, hopefully you remember your order of operations, PEMDAS, or maybe you learned GEMDAS. But remember, we simplify anything in the parentheses first, followed by exponents, and then we multiply and divide from left to right. Finally, we add and subtract from left to right. All right, so if we look inside our parentheses, we can see there's something here that can be simplified. And there's nothing here, but if we go to the other grouping symbol, there is something that can be simplified there as well. So we're going to go ahead and simplify inside the parentheses. So 5 minus -3 is +8, and 4 minus 6 is -2. We then multiply and divide from left to right. So 8 divided by -2 is -4. All right, what about this one? Starting with our grouping symbols, this cannot be simplified. However, in our second grouping symbol, we can simplify this. We can also simplify our first one. So 7 plus 4 is 11, and -3 minus -9, which becomes -3 plus 9. That gives us 6, and we're left with 11 divided by 6. Well, that doesn't divide neatly, so we can write that as a fraction. 11 over 6, 11 divided by 6, 11/6. However you want to read it, it all means the same thing. Let's try to simplify these, reducing all fractional answers again to the lowest terms. So we take 6 minus 2, which is 4, and 40 minus 12, which is 28. I know that 4 and 28 both have a common factor. Both 4 and 28 can be divided by 4. So we're going to do that. We're going to divide both top and bottom by 4 over 4, which is just 1, right? Just another way to write 1 here. 4 divided by 4 is 1, and 28 divided by 4 is 7. So the simplest way to write that answer is 1/7. I know that -1 minus 5 is -6, and 3 minus -12, which is 3 plus 12, is 15. And I know that both -6 and 15 have a common factor. They can both be divided by 3. So in order to reduce that fraction, I want to divide both the top and bottom by their common factor. -6 divided by 3 is -2, and 15 divided by 3 is 5. So -2/5 is the lowest term for that fraction. Our biblical integration comes from this idea that God provided 4 different gospel accounts in His holy word that provide us different insights to the same story. Graphing equations helps us to see written information from a different perspective. We know that graphing shows us the relationship between two things, and I could just tell you about those two relationships. I could talk about those two things. I could give you a bunch of numbers, showing you the relationship, for example, between heart rate and the number of calories burned. Or I could show it to you graphically, showing the relationship between how high your heart rate is and the number of calories that you burn, as an example. The student will find the slope of a graphed line and find the slope of a line passing through 2 given points in today's lesson. So first, you're going to find the slope from a graph, and then you're going to find the slope without a graph, using just 2 given pieces of information, 2 points. The slope of a line, which is represented with the letter M in mathematical equations, is the ratio of the rise, the vertical change, to the corresponding run, horizontal change. Slope can be positive, it can be negative, it can be undefined, or it can be 0. On my wall, you see this little face. I think it says Mr. Slope face. A positive slope looks like this. It's going uphill, and he's got a little plus sign there. A negative slope goes downhill, and he's got a little negative line there. Okay, a 0 slope is just a straight line. If you think about driving on a road that's completely flat, it has 0 slope, so we've got zeros there. And an undefined slope is straight up and down. It's not increasing, it's not decreasing, it's not 0. You can't really define it because it's just straight up and down. So that is our Mr. Slope face to help us keep track of positive, negative, 0, and undefined slopes. Slope describes the incline or the steepness of the line. The coordinates of 2 points on a line can be used to find the rise and the run. Using this point, 3, 1, and B, 5, 4, we can see that our rise, okay, the difference in our y values, it went from 1 to 4, or it went down from 4 to 1. That's a difference of 3. And our run went from 3 to 5. That's a difference of 2. If our slope is rise over run, then our slope is 3 over 2. Let's try to find the slope of this line from a graph. First, we want to choose 2 convenient points. We always want to choose points that are right on an intersection. We don't want to choose a point that's, right here in the middle of the x and y, where we can't really tell what the exact value is. So we want to choose points right here at the intersection of lines. So we're going to choose point A here, -1, 3, and point B here, which is +1, +2. Knowing from our Mr. Slope face, we can see that this is a downward slope, so our final answer here should be negative. If we get a positive number, or if we get a 0, or if we get an undefined number, we've done something wrong. So we know our slope should be negative. Okay, let's find the rise first of all. Okay, we have our y values are 3 and 2. Well, what's the difference between 3 and 2? Difference is 1. Let's find our run. Our run went from -1 to +1. What's the difference between -1 and +1? If we're going from left to right here. If we're going from left to right, our slope went, or our rise went down 1, and it went to the right 2. Rise over 1, we take 3 minus 2, and -1 minus 1. Either way, we get -1/2. Okay, I did 2 minus 3, and I did -1 minus 1, but we still get -1/2 as our slope. We did say it was going to be negative because it's a downward slope, and our answer is in fact negative, so that confirms that we have done that correctly. There is a general formula for this slope between 2 arbitrary points. If you don't have a graph and you're given 2 points, like x and y and x2 and y2, we could find our slope. Remember, slope is just m, using rise over run, and rise is just y2 minus y1. So we take our 2 y's and we subtract them, and our x2 minus x1. You do need to be careful that you do go in this order both times, from y to y and x to x. Okay, don't switch directions and decide to go, let me switch colors so you can see. Don't take y2 minus y1 and then do x1 minus x2. It won't work. So make sure you follow those red arrows there. Go from right to left. All right, let's find the slope of the line passing through 2, -3, and 4, 1. The first thing we want to do is label our x1, x2, and y1, y2. So we're going to use this as our x1 and our y1, and this is our x2 and our y2. Our formula here is m equals y2 minus y1, x2 minus x1. Now that we've written that formula, we're just going to plug and chug. So where it says y2, we're going to write our 1. And where it says y1, we're going to write our -3. Notice that we're using parentheses when we're subbing in, because we don't want to drop that subtraction sign or that negative sign. We need to have them both there. So use parentheses. And then on the bottom, we can take our x2, which is 4, minus our x1, which is 2. When we do the computation, we get 4 over 2, which can be simplified to 2. So our slope is a +2. That's going to go uphill, +2. The slope is the same regardless of which point is considered as the first. So I could have labeled these differently. I could have labeled this as x1 and y1, or x2 and y2. And I could have done it that way, and I still would have found the slope was 2. Okay, you'll see here, if we reverse it, -3 minus 1 and 2 minus 4, I get negative 4 over negative 2 with a slope of 2. So I reverse the points and plug this back in, and I still find the same slope. Let's find the slope of the horizontal line y equals 4 using the points 2, 4, and 7, 4. So let's go ahead and label our points here. x1, y1, x2, y2. That's our first step. Second step is to write the formula. We will write the formula every time so that we can remember it. M equals y2 minus y1 over x2 minus x1. And now let's plug and chug. We're going to plug in y2 minus y1, 4 minus 4, and x2 minus x1, 7 minus 2. We get 0 divided by 5, which can be simplified to 0. Now you may be thinking, how can I divide 0 by anything? Well, think of it this way. If I have $0 and I share it with 5 of my friends, how much do each of my friends get? They get $0. So if you have a 0 on top of the fraction, your slope is going to be 0. The slope of a horizontal line will always be 0. Let's go back to that slope face again. We know going uphill was a positive slope, downhill was a negative slope, and a horizontal line, 0 slope. If you have a 0 on top of your fraction here, that is going to be a 0 slope, a horizontal line. We have one more slope here, our undefined slope that we'll get to in just a little bit. Let's find the slope of this vertical line. X equals 3, using the points 3, negative 2, and 3, 4. The first thing we're going to do every time is label our x1, y1, x2, and y2. After we've done that, we'll then write our formula. M equals y2 minus y1 over x2 minus x1. We'll then substitute in what we know for minus negative 2 and 3 minus 3. Notice again, we're using parentheses to protect our negative. Make sure that you do that. On the top, 4 minus negative 2 is just 4 plus 2, 6. And the bottom, 3 minus 3 is 0. Now, you can't divide anything into 0 groups. You have at least one group. If I have $6, for example, I can't all of a sudden make it go away. Then I don't have $6. I have at least one group. So nothing can be divided by 0. We call that undefined. So the slope of a vertical line is always undefined. And again, on our slope face here, this was positive slope. This was a negative slope. Horizontal line is a 0 slope. And a vertical line is an undefined slope. Let's graph the line that passes through the point negative 1, 2, with a slope of negative 1, 3. 1 over 3, or 1/3. The first thing we want to do is plot our point. So we're going to plot negative 1, 2. So we're going to go to the left 1 and positive 2. That's right here. So we'll plot that point. Okay, after we've plotted our point, we will then move 1 unit down and 3 units to the right. Our top number tells us whether to go up or down, and our bottom number tells us whether to go left or right. So this negative is going to apply to either the bottom or the top, not both. So we're going to use it with our top number here. So negative 1 means down 1 to here. And then positive 3 means 3 units to the right. 1, 2, 3. We'll put a point there, and we can repeat the process. Down 1, over 1, 2, 3. And we would then use a straight edge to connect our line. We could have also put that negative sign with the 3. So we could have gone up 1, whoop, and to the left 3. Negative 3 to the left 3. 1, 2, 3. And put a point there. Okay, if you connect those dots, you'll see that they do form a straight line. Remember, negative 1/3 can either be negative 1 over 3 or 1 over negative 3. So you'll attach that negative sign to just one of those numbers, either the top or the bottom, either the rise or the run, but not both. We then draw a line through the points to see, yes, that is a linear equation. Sometimes finding the slope can be as simple as counting. If we have